Hello, welcome to Algebra 1. We are going to go ahead and start with just reviewing integers for those of you who may need a little refresher in your notes. So an integer, by definition, is our positive and negative whole numbers, or what we say whole numbers and their opposites. So our set kind of looks like this. It takes all these negative numbers here, and then like -3, -2, -1, and 0, and then they're positive numbers on this side. And the dot, dot, dot means it just keeps on going in either direction. And so we're going to go ahead and talk about the different operations and how things work to kind of help get your brain ready for understanding when we start solving equations. So the first thing we're going to talk about is adding integers with the same sign. And so I'm going to use a number line to demonstrate how this typically works. So we're going to start off with 3 plus 5. So I'm going to go ahead and move to the number 3 right here. And then if I were to add 5, I'd go down 5 more. 1, 2, 3, 4, 5, which gives me that answer of 8. Well, on the same token, if we work with the negative numbers, if I start at -3, and then because I'm adding -5, I'm going to add in the negative direction. So now I'm adding 1, 2, 3, 4, 5 in the negative direction, and that gives me -8. So now we're going to go ahead and move down to the next one. 4 plus 9, so I start at 4, and then I'm adding a positive 9, so I'm adding 9 in the positive direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that's going to give me 13. And the same token, -4, so I start at -4, and then I'm adding -9, so I move in the negative direction 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so then I get -13. And so now we're starting to kind of see a pattern that when we're adding our positives, our answer is, positive. And then when we're adding our two negatives, our answer is negatives. And the number without the sign is exactly the same. We have 8 and -8. So they both have an 8, but because the -3 and -5 are negative and we're going negative direction, it stays negative. So using that idea, if we were to add 8 plus 5, we would get 13. But a -8 and a -5 would then give us -13. And so we could use our number line to double check that. So now with different signs, again, we're looking at positive and negative directions. So here I'm starting at a -3, and then I'm going to add a positive 5. So I'm going to go 5 in the positive direction. 1, 2, 3, 4, 5. Now, because I went up in the positive direction, I ended up crossing 0 into the positive numbers. So now let's go ahead and look at our next one. We're starting at +3, and then we're adding -5. So now we're going to go in the negative direction. 1, 2, 3, 4, 5. And now I end at -2, and that's my answer. So let's look at our next problem. And I find that the more I kind of can think mentally about the direction that I'm going, the easier it is to figure out, am I adding, am I subtracting, is my answer going to be positive, is it going to be negative, if I'm visualizing that movement on the number line. Okay, so our next problem is 4 plus -9. So I'm going to start at 4, and then I'm going to add -9. So I'm going to go in the negative direction 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I get -5. And then for the next one, we're going to start at -4, and then I'm going to add +9. So I'm going to go 9 in the positive direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if we look at the patterns here that we're seeing, we're obviously not adding the numbers together in the traditional sense. Like I'm not adding here 3 plus 5 to get 2. Because they're different signs, I actually end up doing a kind of subtraction. And so we can take a look at the bigger number minus the smaller number. So my bigger number 5, and I'm subtracting the smaller number 3. And so my answer is 2. Now over here, I can look at my bigger, and we like to call it absolute value because we're really just ignoring the signs. So I'm going to take my bigger absolute value 5, and I'm going to subtract my smaller absolute value 3. So 5 minus 3 gives me 2. But this one's a negative 2. Why is it negative? It's negative because that bigger number was negative. And so those are just some patterns that we typically tend to see that give us the rules. But again, using that number line will help us imagine and think of that movement that's happening and help us keep straight, is my answer positive or is my answer negative? So using the same idea here, we're going to move down to negative 8 plus 5. 8's bigger, so 8 minus 5 gives me 3. And since 8 was bigger, I'm going to take that sign. So if the 8 was negative, my answer is negative. Same sort of thing over here. 8 plus negative 5. 8's bigger, so 8 minus 5 gives me 3. My 8 is positive, so my answer is positive. So again, lots of different ways to work with these integers. And I find that the adding and subtracting of integers is way harder than the rules for multiplying and dividing, because the rules change depending on if they're the same sign or if they're the different sign, and trying to figure out which number is bigger and all that sort of stuff. And it's not exact opposite, but it is very different than the multiplication and division rule, which just seems to be way simpler. So be careful, addition rules are way different from multiplication rules. Okay, now if we look at subtracting integers, if we do something like 3 minus 5, so 3, and then when I'm subtract, it's the same thing as going in the negative direction. So I'm going to go minus 5, so down 5, and I end up at negative 2. Well, that's the same thing as if we were to start at 3 and then add negative 5. So we'd go in the negative direction. Still gives us negative 2. So we start finding that subtracting a positive is the same thing as adding a negative. It's that same movement on the number line. So if I were to look at the next problem, negative 2, and I'm going to minus 5, so I'm going to go down 5 or to the negative direction 5. 1, 2, 3, 4, 5. I end up at negative 7. Well, that's the same thing as that negative 2 plus negative 5. So negative 2, negative direction 1, 2, 3, 4, 5. So every time we're working with these numbers, subtraction is also the same thing as adding the opposite. Or like we like to say, add a line and change the sign. So 3 minus 9 will be the same thing as 3 plus negative 9. And depending on which version you like to see in your head, people will go back and forth. Some people like the adding the negative better. Some people like subtraction better. And it's all about how your brain processes the information. And so you'll see different people use different methods, but it all ends up in the same way. Okay, so using that idea, we're going to go ahead and talk about the double negative. So if I start off at negative 2, and I'm going to subtract negative 4, so what I'm really doing is I'm going to do the opposite of going negative. So this is opposite of my negative direction. So instead of going down 4, the negative direction, I'm now all of a sudden going to go up 1, 2, 3, 4. Because negative is really saying that we're going to do the opposite of that. So what we really end up doing is taking that negative 2 and we're adding 4 in the positive direction. And so what ends up happening is those negatives are canceling each other out. That double negative becomes plus plus. And really it's just adding an opposite. So if I take 6 minus 3, minus negative 3, start at 6, I'm going to do the opposite of going negative 3. So that's 1, 2, 3, which gives us 9. So that became 6 plus a positive 3. And I always like doing the plus plus because really what's going to end up happening is to save myself time, I'm going to start writing plus plus here. So now I can start thinking about negative 5 plus positive 2. But a lot of times in your notes, it's important to see what the original here looks like and then how it translates to something later. So that way when you start seeing someone's work, you can start seeing, whoa, how all of a sudden this become plus plus, and you see what's happening. So let's look at that. Negative 5, the opposite of negative 2, 1, 2, gives us negative 3. And you are always free if you need to go ahead and draw a number line out. And some people even do what we call like algebra tiles. They'll do negative 5, 1, 2, 3, 4, 5, so 5 negatives. And then they'll take that positive 2, 2 positives, and a negative and a positive cancel each other out and leaves us with an answer of negative 3. So again, lots and lots of different ways to work with integers. You gotta find something that works for you because what's important is that you're consistent with your answers. Okay, so our next one is multiplying and dividing integers. The rules are exactly the same for multiplying and dividing integers. So we're going to work with the multiplication just because it's easier to demonstrate than starting to work about dividing into groups. So the idea we like to use with multiplication is talk about groups. So 2 times 4 is saying I've got 2 groups of 4. So let's go ahead and look. Here's my one group of 4. And I'm going to have another group of 4. And so altogether, that gives us 8. So on my next one, I have 4 groups of negative 3. So I'm going to take a negative 3, a negative 3, a negative 3, and a negative 3. And that gives us negative 12. Now, when we look at the next one, this is where it gets a little bit more complicated. I've got negative 5 groups of negative 2. And really, this is opposite. This is when we're going to start using opposite because you can't have a negative 5 group. That's just not realistic. It's not possible. So I'm going to have the opposite of 5 groups of negative 2. So I'm going to take negative 2, that's 2, 3, 4, 5. But remember, I wanted this opposite. So if my answer here is negative 10, I want the opposite sign, which would be positive. And then our next one is negative 3 times 3. So I can't have negative 3 groups. So this is our opposite of negative 3 groups of 3. So I'm going to do 3 groups of 3, but I wanted the opposite of that, which gives me negative 9. And so when we start looking at the patterns, and this is the one pattern that for some reason resonates with most kids more often than not. Most kids remember these rules. It's the adding and subtracting rules that throw them off. So the rules for multiplication, if they have the same sign, like 2 times 4 or negative 5 times 2, our answer is always going to be positive. If there are different signs, 4 times negative 3, negative 3 times 3, different signs, one's positive, one's negative, the answer is going to be negative. And that's it for our integer review.